So this summer I was researching population variation for epiphyseal fusion, which is the process where juvenile bones grow and develop, and it's specifically where the epiphyses fuse to the long bone shaft. So I was looking at the pattern in which these epiphyses fused to see if there was variation. So we looked at 8 different population samples from 4 different geographic groups: East Asian, North American, European, and African. There were actually a lot of differences in the modal trajectories for each population group. We found that the very beginning sites all remained the same, just because those are some of the most integral sites for fusing. But as we got into the middle section of the pattern in which bones fuse, there was a lot of variation. So the lesser trochanter and the greater trochanter, for example, were flipped in their order, and the distal humerus fused a lot later in one population than the other. So my research advisor, Dr. Maya Sheshal, she collected all of this data during her doctoral dissertation back in 2011. So she traveled the world to all of these skeletal populations and collected data on the fusion as well as other skeletal metrics, and then she allowed me to utilize this data set for the research. One of the biggest contributions of this study is actually its forensic applications. By knowing the actual order in which bones fuse, you can then help distinguish between commingled remains. So when there are mass graves or perhaps a natural disaster and remains are grouped together, by having this specific order, you can then further differentiate between subadults that are usually around the same age